Assalamualaikum and hi everyone. Today we're going to explain about apparatus, technique and reagents. So we hope you will understand it better. Let's get start.
Next, I would like to explain about the analytical balance. There have 5 types of the analytical balance. The first one is single mathematical balance, electronic analytical balance, top and balance, mechanical analytical balance, and the last one is second type of analytical balance. Okay. Balance at the junction is balance near the supply or near flammable solvent. Next, make sure that the balance is healthy and never drop at the balance. The balance should not be placed near an object because it will cause drop. Next, the balance also should not be placed at the direct sunlight. Okay, in this slide, I will explain about the general rules we give. The first rule is we need to warm up for at least half an hour before using the analytical balance. The next rule is never handling object to be wet with the finger. So we need to use clean paper pad to prevent dry object from absorbing moisture. The next rule is center the substance to be wet on the pan. Next, we need to wait at the room temperature. Always lower an object that has been heating to return to room temperature. This will also avoid the error due to a convection currents caused by hot object. Then, never place chemical directly on the pan, but we need to whip them in the vessel. Always brush spilling chemicals off immediately with a soft brush. And the last one of the rules weighing, always close the balance case door before making the weight. Air currents will cause the balance to be unsteady. Okay, there I have 2 types of weighing. The first one is raw weighing and the second one is accurate weighing. Raw weighing is 2 or 3 significant figures are normally used. The accurate weight are reserved for obtaining the weight of a sample to be analyzed, and it must generally be no 2 4 significant figure. Next, I will explain about the weighing technique. There I have 2 types of the weighing technique. The first one is direct weighing. The second one is indirect weighing. Indirect weighing, we hit the balance with nothing on the pen. We need to set to 0 by pressing button on. And then, place weighing water, beaker or pen on balance.
In this video, I will be exploring two fundamental types of laboratory glassware, pipettes and burettes, which play a crucial role in achieving precision during chemical experiment. These tools are commonly used to measure and transfer specific volume of liquid, especially when accuracy is essential for reliable results. Let's begin with pipettes. These are designed to transfer accurately known volume of liquid from one container to another. To use them correctly, we must rinse the pipette with distilled water and then with the solution we plan to measure. After that, a pipette pump or rubber bulb is used to fill the pipette up to its calibration mark, and the outside of the tip should always be wiped dry before use. So next, in this slide, there are two main types of pipette, volumetric and graduated. Volumetric pipettes have a bulb shape and are designed to deliver a single fixed volume, making them ideal for precise measurement. On the other hand, graduated pipettes are straight and marked with volume interval, allowing for flexible measurement of varying volume where accuracy is still required. Next, we have burettes, which are essential in titration procedure. A burette is used to deliver a variable amount of solution drop by drop, especially in experiment where detecting the endpoint of a reaction is crucial. It's typically marked in 0.1 ml increments and can hold up to 50 ml. To ensure accurate titration results, proper technique is key when using burettes. This includes rinsing with distilled water, rinsing again with the solution being used, then filling it using a small funnel. It's also important to eliminate bubbles from the tips and remove any hanging drop by touching the tips against a beaker. Finally, recording the initial reading precisely help track the volume dispensed. This slide shows the classification of laboratory glassware into two main categories, non-volumetric and volumetric. Non-volumetric glassware include beaker and flask, which are typically used for transferring or containing liquid without precise volume measurement, marked with TC, to contain. On the other hand, volumetric glassware include instruments such as volumetric flasks, pipettes, burettes, and graduated cylinder. These are used for accurate measurement of transfer of specific volume of liquid. Volumetric flasks are ideal for preparing standard solution. Pipettes are used to transfer liquid between containers, TC or TD. Burettes are designed for titration process requiring precise dispensing TD. And graduated cylinders are useful for semi-accurate rapid volume measurement TC. This classification helps in choosing the right glassware for different experimental needs.
Next, I will tell you about common heating apparatus in the lab. First, I will tell you about furnaces. It used to ignite sample to a high temperature, either to convert precipitate to a weightable form or to burn organic material prior to inorganic analysis. The temperature up to about 1200 degrees Celsius can be reached with muffled furnaces. Next heating apparatus is oven. It used to dry sample prior to weighing. Oven is well ventilated for uniform heating. The usually temperature employed is about 110 degrees Celsius, but temperature of 200 to 300 degrees Celsius may be obtained. Third apparatus is burner. It used when heating a substance in a beaker or crucible, supported on a ring stand or clay triangle, represent convenient source of intense heat. The maximum temperature attainable from a burner depends upon its design as well as the combustion properties of the gas uses. Next is water box. It used to heat sample at a constant temperature which is stable over a long period of time. Most general laboratory water baths goes from ambient up to 80 degrees Celsius or 99 degrees Celsius. Boiling baths will boil water at 100 degrees Celsius, which is under normal condition. Lastly, the heating apparatus is hot plate. It used for speedy heating up of any solution in a container or under controlled temperature. It also an adjustable heating source, which is ideal for heating beakers, aluminum flasks, hot water baths, and other flat bottom containers. Next, let's talk about ways to keep our dry samples safe after fully dry. We will use desiccator. It is a storage device for dry sample to prevent from reabsorption of moisture after over drying. It used to keep samples dry while they are cooling and before they are weighed, and in some cases, to dry the weight, a desiccant such as calcium chloride, silica gel, CaSO4 or CaO is placed in the bottom to absorb the moisture.